Good day everyone, welcome to my YouTube channel, Math with Ajanako. Today we shall be continuing our class on surds. If you are new to this channel, please hit the subscription button. You might as well want to check out our previous class on surds. Thanks for watching. Today we shall be dealing with expansion of surds and rationalization of surds. Expansion of surds. The expansion of surds is just synonymous or similar to algebraic expansion. For instance, supposing you're told to expand this becomes 5 plus 2 root 2 multiplying 5 plus root 2. 5 plus 2 root 2. And this, according to what we've known before, each of the term of this multiplies this, meaning 5 in this case multiply everything here. That's multiply 5 plus 2 root 2 and plus 2 root 2 here, multiply everything here to 5 plus 2 root 2. And so doing, when I multiply 5 times 5, 25, plus 5 times 2 root 2, that's 10 root 2, plus 10 root 2 again, plus 4 root 4. Now here, simplifying further, this one will give me 25 plus 10 root 2 plus 10 root 2, that's 20 root 2, plus 4 times the square root of 4 is 2, got 2 there, so this becomes 25 plus 20 root 2 plus 8, and this becomes 33 plus 20 root 2. This is simplified. Now also, supposing we are to do this too, this is the same thing, do the same expansion. This becomes root 2 into bracket 3 minus root 3 minus root 3 into bracket, everything here expands this, 3 minus root 3, just how we did in the case of algebraic expansion. Now root 2 times root 3, that's 3 root 3, 3 root 2, then I have minus root 2 times minus root 2 times minus root 3, that's minus root 6, then I have minus root 3 times 3, that's minus 3 root 3, then minus root 3 times minus root 3, that's plus root 9. So this will further give me 3 root 2 minus root 6 minus 3 root 3 plus 3. Now if you look at it closely, there's nothing, there's not more reduction we can do here. They cannot all have the same basic form, so we can't perform any other activity here. The only thing we can do here is to just stop here. So this will be our final simplification. The last one we've gotten here, which is this, if you look at it very well, it looks like different of two squares. Exactly, that's how it looks like. So if you are dealing with these two, let's see, and let's multiply and let's see how it will look like. This is 5 minus 5 into bracket 5 plus root 3 minus root 3 into bracket 5 plus root 3. So solving this further, when you solve this further, this will give me 25 plus 5 root 3 minus 5 root 3 plus minus root 9. So from here, solving further, this will give me 25 minus 5 root 3 minus 5 root 3 minus 5 root 3, that's 0. Then I have minus root 9 is what? 3. So when you simplify further, this should give me 22. Now there's something special about this. If you notice, the former one we've been dealing with, they all give us a rational number. This also gave a rational number, but this gave us a rational number. Now what is the idea? These two surds, they look alike. Of course, that was the reason I told you earlier they look like different of two square. Yes, what we have in between them is the only different thing there, which is the sign, minus and plus. So it makes them conjugate of one another. We call them conjugate surds. This is the conjugate of this, and this is the conjugate of this. So whenever we multiply two conjugates together, it gives us a rational value. So in other sense, this is more like different of two squares. So we can say this is the same thing as 5 raised to power 2 as different of two squares minus root 3 raised to the power 2. And when you simplify this one further, this will give you 25 minus 3. And this will give us 22, which is the same as that there. The idea of this conjugate is needed in rationalization of surds. Now let's discuss rationalization of surds. In surds, we don't leave our denominator in a rational form. So when something like this occurs in our evaluation, what we do next is rationalize. How do you rationalize? To rationalize, you have to, rationalizing means making the denominator a rational value, making the denominator rational. And to do that, you have to multiply the denominator with itself. So as it becomes a perfect square, then find the square root of a perfect square, it becomes rational. Meaning this becomes 2 all over root 3 times root 3 all over root 3, because whatever you do to the denominator, you must do it to the numerator too. So this becomes 2 root 3 and the denominator becomes root 9. So simplifying further, this becomes 2 root 3 all over 3. So you just rationalized. You've made the denominator a rational value. So likewise, if you are to do these two, the same thing will happen. Root 2 over 3 root 3 becomes, this becomes 3 root 3 over 3 root 3. You multiply by what? 3 root 3 over 3 root 3, because that's what can make the denominator a rational value. Now then this becomes 3, because the coefficient here is 1 times 3 3, root 3 times root 2 times root 3, that's root 6 over 9 root 9. Then simplifying further, this will give me 3 root 6 over 9 times 3. Now 3 cancel out this 3, so this becomes root 6 all over 9. So now in this case, to rationalize this is so very simple, but just what the aim is to make the denominator rational, and the only way to make this denominator rational is to multiply it by its conjugate, which is what you've learned earlier. Multiplying this one by its conjugate, this becomes 2 over 3 minus root 2 times the conjugate of 3 minus root 2 is 3 plus root 2 all over 3 plus root 2. Now simplifying further, this will give me 2 into bracket 3 plus root 2 over 3 minus root 2, 3 plus root 2. Now this becomes 6 plus 2 root 2 over different of two squares, that's 3 raised to power 2 minus root 2 all raised to power 2. Simplifying further, this one should give me 6 plus 2 root 2 over 9 minus 2, and this will give me 6 plus 2 root 2 over 7. Just rational. So from the fourth question, we are to rationalize this. Now, to rationalize this, you multiply by the conjugate, just as we said. This is times root 2 plus root 3 over root 2 plus root 3. On solving this, this becomes root 2 plus root 3 multiplied by 1 over this root 2 raised to power 2 minus root 3 raised to the power 2. That's different of 2 squares. So this becomes root 2 minus plus root 3 all over 2 minus 1. This is equal to root 2 plus root 3 all over minus 1. And this is equal to minus root 2 minus root 3. So that will be all. Now that's going to be the answer. So that will be all for today. Please don't forget to subscribe to the channel if you haven't already. Hit the like button and share our video. Thanks for watching.